So yesterday we kind of briefly went over these two. You don't need to write them down again by any means, but just to kind of recap. So we said if we had a function that was like 2 to the x, it crosses through here, right, like that. We said that the domain was negative infinity to positive infinity. The range was 0 to infinity. It has an x-intercept, no x-intercept. The y-intercept is at 1. We said it has a horizontal asymptote at 0. No vertical asymptote. It's increasing and going up, and it's 1 to 1. That's what we said yesterday. And then we also had exponential decay, which the only thing that's different about that is the a is basically a fraction or decimal. So if I change this to 1/2 to the x, that'd be exponential decay. And it looks almost the same except it goes down. And this is all the same. So this just decreasing. So that's what we did yesterday along with the Desmos if you weren't here for some reason. So today we're going to be graphing these with a little bit more going on. But first, we're going to do a little rewind here of what the different transformations were. And this should be pretty much a review, so I think you'll find the graphing of these is pretty easy. These are like the 4 major transformations that we do. So the first one is a vertical shift. And I'm just going to throw some examples here. Each one. Let's say we have f of x is, we use the function 2 to the x and plus 3. Up there. What does that plus 3 tell us to do? Add 3. So what does it do to that? Yeah, it moves it up 3. This tells us to shift up our function up 3. So move the whole thing, move everything about that function up 3. And notice this is on the outside, we would say. So it's going to change the y's. We're going to move all the y's up 3. And then the opposite would be if we have, let's say, 2 to the x minus 2. That's the opposite effect, right? Minus 2 out here, and we move it down. Now, you can also see, I think one of the problems that you guys are going to graph has it written in a different order. Like you could also write this as 3 plus 2x, and it would have the same effect, just the 3's in front, so you would still move it up 3. But those are equivalent. You would still do the same function and move it up 3, just in a different order. So if you see something switched, notice it's actually the same thing. All right, let's do a horizontal shift next. Do a horizontal shift, that plus and minus is just going to go in a different spot. We'll say 2 to the x plus 3 up there. So it's 2 to the x plus 3 versus 2 to the x plus 3. Just kind of pause a second, I guess, when you say it. Well, what does that do when we have a plus 3 up there? Over which way? It's the opposite, sorry. Yeah. It's the opposite when it's in there. Yeah, it's going to be left 3. It's always the opposite when you move left and right. You think right is just plus, but then it's left. It's the same as we think of this up and down. And then, so let's just use this other one. Let's make it 2 to the x minus 2. Yeah, there we go. Right. Then we can also have stretches and compressions. That's when we multiply by something. So let's say we have 3 times 2 to the x. So always kind of look like that with a number times and then our exponential function. And that's going to stretch it and we stretch by a factor of 3, what's going to actually happen to our graph, I'll show you, is instead of crossing at 1, generally it crosses at 1, it's going to actually go up to 3 and cross at 3. It's still going to go down here, but it just changes the place where it crosses. So that's the main effect that's going to have. It's going to stretch it up, and so instead of crossing at 1, this would actually cross at 3. And we'll see an example where that happens. And then we could also have a compress or a shrink, if you will. It was like 1/2 times 2 to the x. Multiply by a small fraction. I could say a compress or a shrink. But it's actually going to do the same thing. This would just tell us we're going to cross at 1/2 instead of at 1. Sort of smushes it down to the top. And then we got 2 reflections. See if we can remember which one's which. It's always hard to remember which one is which axis. So let's start with negative out in front, 2 to the x. We know with the negative it's going to be a reflection, but it's often hard to remember which one it is. Right? Is it a reflective of the x or the y?
No.
Those are the options. The options are x or y.
X.
Oh, you're right, actually. All right. Good guess. So this is a reflective of the x.
Oh, that's a yes.
Seems like you didn't know how to answer it the first time. Alright, so that's a reflective of the x. What it does, though, is it changes the y's. I always like to write that, because every time you do something like sort of outside of the x, so like this, you can think of it as being outside, it changes y coordinates, it moves up and down. This one, it's sort of inside the function, it's next to it, moves it left and right. This one is outside of the function because it's not next to the x, so it changes the y's. So it's going to reflect it over the x-axis. So the x is this way, so it actually will change the y's, the y coordinates. And then the opposite would be if we have 2 to the negative x up there, that's going to be the other one, which is going to be reflective of the y-axis. So that's going to stay the same, and that changes the x's. And I'm going to pass out some coordinate plane paper because we're going to be graphing here. And if you don't want one, you don't have to use it, but you might want it for your assignment problems and you have to just hang on to it. If you'd rather write them in your notes, that's fine, but this is just to write it. I've graphed a lot of other things, so this I think is actually one of the easier ones. And if you don't use it for your notes, you now use it for your assignment problem. So. All right, so let's try one here. So we're going to graph this. We're always going to do the parent function as well, which is just the original exponential. And then I want you to always write these 3 things as well: the domain, the range, and the horizontal asymptote. We're going to do all that. We're going to graph it using transformations. So this is going to be a sketch. It's not going to be like every point is exactly the right spot. It's going to be a sketch, meaning that the main features are going to sort of be intact here. So let's start with the parent function. All of the parent functions cross through 1 right there. So that's where you're always going to put your first mark, because it crosses through 1. And then this is 2, So it's bigger than 1, which means it's going to be exponential growth. So we're going to go up, it's going to be infinity. And then also, always put the horizontal asymptote as well. That might move, but we want to put it there to start. So I would always start with parent function. If you have a different color, it would be a good idea to use a different color. Because you got 2 different writing pencils. If not, it's okay. All right, and then we're gonna just figure out the only transformation we have. This one, it's up 1. So there's 2 things we're gonna move. We're gonna move this 1 point always, move it up 1, and then we're also gonna move the asymptote if we're moving up and down. So the asymptote gets moved up 1, like that, and that's it. So we're just gonna draw the same shape. It's just everything shifted up 1. Just make sure you never cross the asymptote. Never cross it. That's it. Now we just need to identify the domain, the range, and the asymptote. The domain on these will be easy because it's always the same. No matter what you do to this function, it's still going to go all the way to negative infinity and all the way to positive infinity in the x direction. So that will always be negative infinity and positive infinity. You can just write all reals if you want to as well. So there are the range. This might change. Depends on that specific one. It did change in this one. What is the range of this function? Yeah, I mean, yeah, 1 to what? Good. 1 to infinity. Because we're at the blue one now, it never goes below 1. So 1's like the lowest point, always in the lowest, up to the highest. So our asymptote will always tell you what the range is. The asymptote moved up 1, so then like our range shifted up 1. It was 0, now it's 1. Alright, and then the horizontal asymptote. That was y equals 0, it just shifted up 1, so now it's y equals 1. And that's all you gotta put. Again, it's a sketch, it's not like every point isn't in the exact right spot, but we know where it crosses, we know where the asymptote is, we know generally what that looks like. That's good. Easy enough, right? Alright, let's try another one. Another easy one. 3 to the x minus 1. And the 1 is up in the exponent. So we still want to start by graphing the parent function. So I'll just do that. You don't have to, but I would. It's exponential growth. It's a 3 this time, but it still crosses at 1. So no matter what that face is, if it's 3 or 5 or whatever, it's still going to cross at 1. Okay, now, what's our one transformation here? What's that tell us to do? Right. Right, because it's up in the exponent. And then, so let's graph our new function. All we're going to do is move this 1 point right 1. The asymptote, moving it right 1 doesn't really do anything, right? Just still the asymptote is still there. So it's just going to be same function, just shifted right 1. Okay. Domain is still the same, just do all reals. The range, and then it shifts up or down, so the range will stay 0 to infinity. And the horizontal asymptote didn't move, so it stays at y equals 0. We get a little bit harder here. Let's throw a couple. 3 to the 3 times 1/2 to the x plus 2. All right, now be careful when you draw your parent function on this one though, because this is a 1/2, which means it's exponential decay. So we're still putting 1 at 1. We still have our asymptote, but instead of increasing, it's going to be decreasing. You just make sure it doesn't cross your asymptote. Okay, so let's figure out everything we've got going on here. This is just the base, so we don't have to worry about that 1/2. This tells us we're going to stretch it. Okay? And then up here, this is going to tell us to go left. Right. So the stretch, this is the one that's maybe just a little bit different. The stretch means we're going to essentially multiply everything by 3. So this 1 is going to go up to 3 instead. So that 1 gets stretched up to 3. We're going to move it over as well, but that's sort of the first thing. We don't have to draw all 3 of them. But after that 1 goes up to 3, it just sort of gets stretched up to 3. Normally there's just like an invisible 1 there that tells us we crossed the 1, but this one has a 3, so we're going to stretch up to 3. And then we're going to go left 2. So our point's actually going to be right there. But we didn't move the asymptote. Even though we stretched it, we didn't move the asymptote as well. So we're going to actually still going to go all the way down to the asymptote down there. So don't like shift that up just because we stretched it. Stretch it just means it's going to grow a little bit faster. So again, don't change the asymptote. It's only if you shift up or down. Still want to make sure it goes to the asymptote. So this one sort of dies off faster here, whereas this one still continues to go down. And we still got to do our domain range. So, domain's always the same, all reals. Range actually didn't change, right? We didn't move the asymptote, so it's the same 0 to infinity. And even though it like starts up at infinity, we still write the 0 first. Always write the lower number first. Then the horizontal asymptote, still same place, y equals 0. I want to do a reflection here as well. Next one. Last one. All right, 3 to the negative x minus 2. So the parent function is going to be the exponential growth one because it's a 3. We're going to cross at 1. Our asymptote. Increasing. All right, now our two things are we're going to, this one's going to be down 2. And this one tells us to reflect, is it over x or y? Good. Which means we're going to change the x's. It doesn't really matter the order that you do this. Still the same result. Let's go ahead and move it down 2 to start. So we move the asymptote down 2. We move this point down 2 as well. And then if we're going to reflect over the x-axis, reflect over the y-axis, it's going to change the x's. So the y-axis will be this way. So what happens is this gets flipped over here, and this part gets flipped over there. So it ends up looking like this. It actually turns into exponential decay. Because if you remember when we did the Desmos, how like 1/2 to the x was the same thing as 2 to the negative x. Remember that yesterday? Those were the same things. Those are actually equivalent ways of writing it. So if you see a negative x power, that means it's actually just going to end up being decay. The domain is going to be same as always, all reals. Range now is -2 to infinity. -2 is our lowest spot. And then the horizontal asymptote at y equals. Just feel good about that? Good. So I'll give you the rest of the period to work on some problems. And it is posted on Google Classroom. I'll put it up here as well. The first section is actually a bit tricky. It doesn't seem that hard, but I'll pull that up here and show you. Yeah. So the first part is actually just matching 34 to 42. You have to match some graphs, and then you got 5 of them you're going to graph. Let me pull it up though again just to show you real quick here. It's on 2 different pages because for whatever reason they put the functions at the bottom of page 290 and then they put the actual graph on the next page, 291. So what I'm going to do is pull up the functions up here so you can actually see them while you're looking at the graphs, so you don't have to like flip back and forth. But it's just a bit challenging figuring out which ones they go with. So don't spend too much time on this. The other class I ended up just going over like 5 minutes into the class, 5 minutes into working on them. So we can do that too if you guys want to. Let's see if you can match up these with the graphs of the other picture. And then we'll talk about it. If you're getting stuck, again, don't worry too much. The main thing I want you to be able to do is to graph them. But they're all so similar. They'll have 3s and 1s and some have negatives. So it can be a little bit confusing. So give those a shot and then we'll go over them in like 5 minutes.